Okay, this video is a part of 21A. The topic first is dealing with increasing and decreasing functions. To find where a function increases, you're looking where the function is going up or has a positive slope. To find where a function decreases, you're looking for where the function is going down or has a negative slope. So if you want to go ahead and highlight anything on this slide, I would suggest when a function increases, it's going to have a positive slope or going up. When it is decreasing, you're going to look to see that it's going down or it has a negative slope. So here's an example that we have. Here is a curve, and we want to find out where is it increasing, decreasing, and constant. So let's start off with point A going to point B. What's happening there? We have a positive slope, so it is increasing. And then we go from point B to point C. Our slope is negative, so we say that it is decreasing. And then from point C up to D, it's a positive slope, it's rising, so it is increasing. If we're given an equation, sometimes we have to find out when is it increasing or decreasing. So algebraically, when you see an inequality like this is saying x is greater than or equal to 2. So on a number line, it's a closed circle going to the right. Next one, x is greater than 2. Open circle to the right. Next one, this is saying x is less than or equal to 4. Closed circle, left, smaller. Next one, x less than 4. Open circle, less than, left. Now we have a compound inequality. This is saying x is greater than or equal to 2 and less than or equal to 4. So both of them are closed circles going together. This last one is saying x is greater than or equal to 2 and less than 4. So it's going to have an open circle. So if we look at intervals for which is increasing, here's a person increasing positively throughout. This one decreasing. All right. So there will be times where we need to figure out interval notation. So intervals are going to have parentheses and brackets included. So here's some examples of increasing and decreasing functions. So here's our function, y equals 2 to the x. When we graph it out, it's an exponential equation. What's happening to it? Throughout the entire function, it's increasing. So it's increasing throughout the entire function. So it's increasing from negative infinity to positive infinity, if we write it as an interval. Example 2. Here is the function, y equals 3 to the negative x power, another exponential. But notice what's happening now. It is decreasing for all of x. So it's decreasing through this entire interval from negative infinity to infinity. Another interval notation. All right. Next example, example 4. The function is a quadratic function, a parabola. So when we move to the left here and going down, this has a negative slope. So if here is 0 and this is the x-axis, everything less than x is decreasing. So it's decreasing when x is less than or equal to 0. Now if I change colors, what's happening when you go to the right of 0? It changes to a positive slope. So it's increasing for x greater than or equal to 0. All right, next example, example 5. Find the intervals for which the function is increasing and decreasing. So here's our curve, and we want to find out where are the intervals it's increasing. So here is the first piece where it has a positive slope. How do we write that in interval notation? Well, this is always on the x-axis. Think of this as negative infinity. And where does it stop on the x? Right here, at -1. So that first red piece, how you write this in interval notation is negative infinity, comma, -1. Or as an inequality, x is less than or equal to -1. So you're probably more comfortable with inequality notation than interval notation. But we'd like you to get to the habit of more doing interval notation. All right. All right, then what happens? At -1, it changes and starts to decrease in that region. So this interval is, again, at -1. It's where it starts to change direction, and then it stops when x is 2. You're not worrying about the y's, you're only worrying about the x's. So how do we write this interval? So always on the x-axis. So as an interval, it decreases from -1, comma, +2. So that's as an interval. It's not a ordered pair. Or as an inequality, we would say like this. X is greater than or equal to -1 and less than or equal to 2. All right, last piece. Then at 2, it starts to increase again, positive slope. So it doesn't stop, it goes on forever. So when x is 2 and to the right, think positive infinity, it increases. So to write that as an interval notation, it starts at 2, comma, to infinity. Or as an inequality, x is greater than or equal to 2.